welcome back. So now let's put everything we have learned so far together to evaluate trig ratios for angles in degrees and radians. So Melvin says, so we'll graph the angles using a reference angle. And Felipe says, then we'll use special triangles to find the trig ratios. Melvin says, I'm really getting this trig stuff, Felipe. Me too, Melvin. All right, so we've got Melvin and Felipe helping us to evaluate trig ratios for angles in degrees and radians. And on this Nearpod, we're going to just look at degrees. On the next Nearpod, we'll look at radians. Here, let's go through this a little bit in terms of our reference triangle, which is essentially our reference angle made into a triangle. And then we'll go through the steps to evaluating our reference triangle. So for our reference triangle, you're going to drop a perpendicular from xy to the x-axis. So here, if this was our reference angle, right? So let's say this is our reference angle. This angle right here. To create a reference triangle, all you have to do is simply go from our angle back to the x-axis. And we're not going to be even graphing these on coordinate. We're going to graph them on coordinate planes, but they're going to be coordinate planes that look like this. All right, so they're not going to be necessarily drawn to scale. Right, they're going to just include the quadrants. Right, because our angles are going to tell us the special right triangle to use. Right, and the value, no matter what size a triangle is, similar triangles have the same trig ratio, regardless of the size of the triangle. Right, so that's why we don't need any values on this, because we have special right triangles, right? And no matter what, our trig ratio would reduce to the same amount. So if we drew a bigger triangle, it wouldn't make any difference. It wouldn't make any difference to the trig ratio because it would still reduce to the same amount. All right, so here's our steps. We're going to drop a perpendicular, right, to the x-axis. This forms a reference triangle. We can use the reference angle to find the trig values for the given angle. So remember, the reference angle is measured from the terminal side of the original angle to the x-axis, never the y-axis. So we're never going to the y-axis, just the x-axis, because our angle is nestled right there next to, let's just call that beta because we already have a theta, next to the origin. Here are our steps to evaluating the trig ratios given the angles. All right, and I have the steps. It doesn't matter whether it's in degrees or radians. We'll see degrees in this Nearpod. We'll see radians in the next Nearpod. So first we'll draw the angle. Right, that's our so this angle here is the principal angle. And if the angle that you're given is not between 0 and 360, you'll have to find a coterminal angle first. So you have these steps in your notes. Just add the word principal in front of angle and find coterminal angle if angle is not between 0 and 360 degrees. And of course in radians, that's 0 and 2 pi. And that's a little and symbol there. All right, so we have to be in the correct quad. We need an angle that is going to be in between 0 and 360. We don't want to go around the circle. All right, so here we're going to find our reference angle in degrees. Our reference angle is going to be 30, 60, or 45 degrees. Now your reference angle can be any degrees, right? Any degrees that are between 0 and 90. However, we can only evaluate for certain angles, and those certain angles are angles of 30 degrees, 60 degrees, and 45 degrees. So while we can find a reference angle that measures anything between 0 and 90 degrees, we'll only be evaluating reference angles that are 30 degrees, 60 degrees, or 45 degrees. In radians, that's pi sixths, pi thirds, or pi fourths. We'll find that reference angle by drawing a line perpendicular with the x-axis. We'll use special triangle relationships to find the sides of the triangle. We'll set up the trig ratios for the reference angle, and we'll choose the sign based on the quadrant of the terminal side of the given angle. Because remember, different trig functions have different signs based on what quadrant we're in. In the first quadrant, they're all positive. In the second quadrant, only sine and cosecant are positive. In the third quadrant, only tangent and cotangent are positive. And in the fourth quadrant, only cosine and secant are positive. All right, so here's the steps. You have that in your notes. And let's graph our first one. All right, so this one is in the notes. I think there are 3 examples. And yes, 3 examples, and we're going to do them all in your notes. All right, so first, use the reference angle to find the exact values for all 6 trig functions for a 315 degree angle. All right, so remember, this is 0, this is 90, this is 180, it's half a circle, 270 is 3/4 of a circle. So notice that is more than 270, but less than 360. All right, so we have a principal angle here. All right, so our angle is going to be in the 4th quadrant, right? Because it's more than 270, but it's less than 360. So let's draw our reference angle. Let's draw our principal angle. So this right here is the principal angle that we've drawn. All right, this is 315 degrees, and you should show this in your notes. Here's our terminal side right here, right? I'll just label it, just to remind us. All right, so that's the terminal side of the angle. Now, for the reference triangle, it goes from the terminal side back, right? Back to the x-axis. All right, that line is going to be perpendicular with the x-axis. What we care about here, though, is what is the measure of theta. Now, we're in the 4th quadrant. I'll label that. So for the 4th quadrant, the reference angle equals 360 minus the principal angle. All right? So there is enough room, I believe, for you to put this in your notes. Feel free, though, to abbreviate, right, to make sure you have enough space, because we still have to do all the trig functions. And I better think about that, and I'm going to move this up here. So that means that the reference angle, I'll abbreviate that, is going to be 360 minus 315 degrees, or 45 degrees. Right? So theta here, which is our reference angle, is 45 degrees. All right, so now we know the sides of a 45, 45, 90 special right triangle. All right, so remember, so if this angle there is 45, of course, this angle here, although not one we can evaluate on a coordinate plane, because that's not at the origin, would also be 45, right? This is a 45, 45, 90. There's only 45 degrees left for that angle. So we know that the leg, so when we write our values in, like I could write any value in, right? So long as I made these two the same, right? Because a 45, 45, 90 is an isosceles right triangle. There's no point in me saying 8, 8, right? Because when we come up with our trig ratios, it's going to reduce, right? If I had 8 over 8, that would just reduce to 1. So we're going to use the smallest numbers possible, right? So on the 45, 45, 90, we have our legs at 1, and we know that the hypotenuse is going to be the leg times the square root of 2. And I'll just write that in to remind us. I'll put it over here. All right, so hypotenuse, and this is for 45, 45, 90. That equals the leg times the square root of 2. So in this example, it's going to be the square root of 2, right? Because 1 times the square root of 2 is the square root of 2. All right, so now we need to label our sides relative to our angle theta here, relative to our reference angle. Across the triangle, the y value is the opposite. Adjacent to the angle, of course, is the adjacent side. And the hypotenuse is always opposite the right angle. All right, now that we have our sides labeled, we can identify all of our trig ratios. All right, so sine theta is opposite over hypotenuse. I'll write this into. So if you can, and you only have to write the trig, the value, that the formula here for sine, cosine, etc. once. I'll make that optional, but the more that you have, the more valuable your notes are. All right. So if you can fit everything in, that would be great, and you'd have a good reference. So sine theta is going to be equal to opposite over hypotenuse. The opposite is 1. The hypotenuse is the square root of 2, and of course we're going to rationalize by multiplying by the square root of 2 of the square root of 2. So that means our sine ratio is the square root of 2 over 2, except for one slight little thing. I went over this. Don't forget to choose the sine based on the quadrant of the terminal side of the given angle, and then I forgot to put the sine in. So at least I didn't get very far. Right away I realized, whoops, missing the sine. So here x is positive and y is negative. So that should be a -1. So let's make this a -1, right? Because the opposite side is negative, which makes this negative square root of 2 over 2. So don't forget your signs. Cosine theta uses adjacent over hypotenuse. So that's going to be +1 because it uses the x, and the x is positive, over the square root of 2. And then, of course, we'll rationalize it. And so that will be the square root of 2 over 2. Hope I have enough room here myself. Tangent theta is the opposite. I'm just waiting for my words to come up. Taking its sweet time. Maybe it's not coming up. There it is, or it's coming. There it comes up very, very, very slowly. And look at my equal sign. I got an extra letter in there. Extra line in there. So tangent theta equals opposite over adjacent. The opposite side is -1. The adjacent side is 1. That's -1. All right, so now we have our reciprocals. So we have cosecant theta. All right, so that's going to be the square root of 2. All right, actually, let me write the sides in. So cosecant theta uses the hypotenuse over the opposite side. You know, if I move this up, I could move all of this up, and I might be able to squeeze everything in. Okay, there. Yep. All right, so cosecant theta is hypotenuse over opposite. The hypotenuse is the square root of 2. The opposite side is -1, so that's going to be negative square root of 2. All right? Or we can remember that they're all going to be negative in the fourth quadrant except for cosine and secant. Secant theta is hypotenuse over adjacent. So that would be the square root of 2 over 1. That's just the square root of 2. And last but not least, we have cotangent theta, which is adjacent over opposite, or 1 divided by -1, which is just -1. All right, so now this is just like when we were finding the trig ratios at the very, very beginning, and we had a triangle, right? And we just identified opposite, adjacent, hypotenuse. The difference is that you're not given the triangle, you're given an angle. You're going to use that angle to find, you're going to draw that angle. So that's step one. You're going to use that angle to find the reference angle. Once you have the reference angle, you can use special triangle relationships to find the sides of the triangles. And then you'll set up the trig ratios for the reference angle. Right? So once you've got your reference triangle drawn, you're going to have a special right triangle, and you'll use the special right triangle relationships to find the sides, and then you can find your trig ratios. All right? And then we're going to do the same steps, same 5 steps, 2 more times. All right? Let's do 2 more examples. And now that I've gone over it, I can probably go over it just a tad faster. And all 3 of these are going to be in your notes. All right, so here we're going to use the reference triangle to find the exact values for all 6 trig functions for a 120-degree angle. All right, so you're taking all the things you've learned and you're putting it together to evaluate angles. And that's going to be a key skill as we're moving forwards. All right, so this is 0, this is 90, this is 180, this is 270. So 120 is greater than 90, but less than 180. So it's roughly there, right? So this will be the 120-degree angle. In the second quadrant, I'm going to write it up here, just to save a little bit of space. I'll switch colors. The reference angle equals the principal angle, excuse me, I'm thinking of the third quadrant. The reference angle equals, and we're in degrees, equals 180 minus the principal angle. So in the first quadrant, the principal angle is the reference angle. He's his own reference angle. In the second quadrant, we take 180 and we subtract the principal angle. In the third quadrant, we subtract 180 from the principal angle. And in the fourth quadrant, we subtract from 360. So this right here is going to be the reference angle, the difference between our principal angle and the x-axis. Right? So there you go. There's your right triangle. You just draw that line perpendicular to the x-axis to find the degrees. Right? Our reference angle is going to be 180 minus 120, or 60 degrees. All right, so make sure you know how to find it for the 3 quadrants. So this angle here, theta, is 60 degrees. Now this is the 30, 60, 90 right triangle. And if you remember, the long leg, let's build everything off the short leg, because we can find any leg, but the easiest would be the short leg. I don't know how that happened. I'm not even touching that keyboard, I have to tell you. So the long leg equals the short leg. Let's put short. Times the square root of 3. And the hypotenuse is 2 times the short leg. Now, of course, just like the 45, 45, 90, we can put any value we want. But in the end, it's just going to reduce, right? So if I make one side 10, right, I'm going to have a side that includes a 10, and that 10 is just going to cancel out. So let's make it as simple as possible. What's the simplest number you can think of? Of course, it's 1. Now, where does the 1 go? If our reference angle is the 60, and the right angle is shown, the 30-degree angle has to be over here. Right? So shorter side is opposite smaller angle. So the short leg is opposite the 30-degree angle. This is 1. Opposite the 60-degree angle is 1 times the square root of 3. And the hypotenuse is twice the short side. So this is the short leg, and the short leg is the adjacent. I don't really need to write short in there. is the adjacent side. It's along the x. In the second quadrant, x is negative, right? So this is, the x is negative and the y is positive. Okay, so that is trying to be -1. There we go. The opposite side is the square root of 3, and the hypotenuse is 2. I'll make that look a little nicer, and I'll just abbreviate. So you should put this part in your notes, because these are the exact same steps that you're going to do to evaluate an angle. All right, you're going to graph your principal angle. You'll find your reference angle by using the correct rule for the quadrant. And then it's going to be the sides of a special right triangle. You label the sides based on the angle they're opposite. So it's either going to be 45, 45, 90. The legs are 1. The hypotenuse is the square root of 2. Or it's going to be 30, 60, 90. Opposite the 30-degree angle is 1. Opposite the 60-degree angle is the square root of 3. And the hypotenuse is 2. And then look to see what quadrant you're in to determine whether x or y are negative. So like I said before, I can choose any number I want. I could have made the adjacent side -10. But when I create my ratio, let's say it's adjacent over opposite, I would be having then, so if my side was 10, right, the long leg would be 10 square roots of 3. Notice that would just cancel out, right? So there's no point in making it anything but the simplest value possible. Okay? Just wanted to make sure that it was clear why we start with a 1. The simplest number we have. All right, so now let's come up with our trig ratios. If you already wrote one before on the last slide that sine is opposite over hypotenuse, you can still see that because all three graphs are on the same page, but they're not on the same page for me. So I'll write it here just to make sure I'm reviewing that and making sure it's clear for everybody. All right, so we have found the reference angle. That was 60 degrees. Actually, let's go through our steps from the beginning. We drew the angle. We drew the principal angle. We found the reference angle. We used special triangle relationships to find the sides of the triangle. So now we're going to set the trig ratios for the reference angle. If you label that your sine, if you do that over here, when you're labeling your sides, you don't have to worry about it afterwards. And so I've already labeled the adjacent side is -1. And if we remember, the only one, everything's going to be negative in that second quadrant, except for the one that does not use the adjacent side, and that is sine and cosecant. So sine theta is opposite over hypotenuse. That's going to be the square root of 3 over 2. We're done with that one. Cosine theta is adjacent over hypotenuse. That's going to be -1/2. Tangent is opposite over adjacent, and that's going to be the square root of 3 divided by -1. That's just negative square roots of 3. We can simplify that. Cosecant theta is hypotenuse over opposite. So that's going to be 2 over the square root of 3. This one needs to be rationalized because it's got a radical in the denominator. So we'll multiply numerator and denominator by the square root of 3. So that's going to be 2 square roots of 3 over the square root of 9. The square root of 9 is just 3. Then we have secant theta, which is hypotenuse over adjacent. Hypotenuse is the square root, hypotenuse is 2. Just 2. The adjacent side is -1. Right? That's just going to be -2. And finally, let's put cotangent over here. Cotangent is adjacent over opposite. So that's going to be, we're going to have to rationalize that. I hope I have enough space. Let me just move them over just a tad. So that's going to be -1 over the square root of 3. If we rationalize that, all right, no room for cotangent there. How about we put them down here? You put them wherever you have space for them. There he is. And then if we simplify that, that's going to be negative square roots of 3 over the square root of 9, which is just 3. And there we go. All right, so we have evaluated all 6 trig ratios using a reference triangle. All right, and we're going to do the exact same steps every single time. Right, the only difference is going to be what quadrant is it in. Right, that'll determine how we find our reference angle. Right, and then which triangle is it? Is it the 45, 45, 90, or is it the 30, 60, 90? Right, and in the case of the 30, 60, 90, which one's the adjacent and which one's the opposite? Let's do one more. See if we can get this done in no more than 30 minutes. So let's try this one. This one is -30. And this time I left the steps off. We have oodles of space because it's the same steps. So this is 0 degrees. If we're going in the negative direction, this would be -90. This would be -180. And this would be -270. So -30 is going to be right about there. Actually, that looks a lot more like 45, doesn't it? Let's just make that look more like a third. There we go. So here is -30 degrees. Our angle is negative, so let's find a coterminal angle. So our principal angle, we will find a coterminal angle between 0 and 360 degrees. All right. So -30 is not between 0 and 360. So our principal angle is going to be -30 plus 360, right? Because our coterminal angles are 360 degrees apart. We can find more by simply adding or subtracting 360. So that's going to be positive 330. So a -300 and let's graph our angle here. So a -30 degree angle is the same as a positive 330 degree angle. And maybe already in your head you know what the reference angle is going to be. We are now in the 4th quadrant, so our reference angle is going to be 360 minus the principal angle, which in this case is 360 minus 330, or 30 degrees. All right, so it won't always work out that your reference angle is just the opposite of your principal angle when it's negative. It just happens to work out okay this time because our angle was between 0 and 90 degrees. It was just negative. All right, so here is what our reference angle is going to be right here. So theta here is 30 degrees. All right, so now if you remember, this is just the 30, 60, 90 triangle. Only this time, right, the opposite is the short leg. The adjacent is the square root of 3, is the long leg. And of course, the hypotenuse will always be 2. All right, so if opposite the 30 degree angle is always going to be 1, the 60 degree angle would have been up here. Opposite the 60 will be the square root of 3, and then opposite the right angle on 30, 60, 90, the hypotenuse will be 2. Now let's just make sure our signs are correct. All right, square root of 3 is good. X is positive in that quadrant, but that one should be negative. All right, so now we can find our 6 trig ratios. Let's label our sides too. So the -1 is the opposite side. The square root of 3 is the adjacent side, and the 2 is the hypotenuse. All right, so, and you don't have to write that sine theta. You just write sine theta. You don't have to write opposite over hypotenuse because you already have it on the same page. All right, so opposite is -1, hypotenuse is 2. We're done. Cosine theta is adjacent over hypotenuse. Right? And the adjacent side is the square root of 3. The hypotenuse is 2. Notice cosine is positive in the 4th quadrant. Tangent theta is opposite over adjacent. Boy, my thetas are looking kind of So the opposite side is -1. The adjacent side is the square root of 3. We should rationalize that. And so that's going to be negative square roots of 3 over 3. So notice you get the same values as you did on the other triangle, except it was the, I just wanted to show you real quick. There you go. In this one, it was the adjacent side that was the 1, and the opposite side, that was the square root of 3, right? So our values are switched a little bit depending on who uses opposite and who uses adjacent, right? And in this case, the adjacent was negative and the opposite was positive. Over here, it's reversed. It's the opposite that's negative and the adjacent is the positive one, right? But so all of these are really just going to be involving the same values. The signs will change, right? Which value is opposite and which value is adjacent will change, right? But they're all just special right triangles, right, that we're using to evaluate our angles that are between 0 and 360 on a coordinate plane. All right, let's finish these last couple. I want to be done in 30 minutes, but we're going to be close. All right, so cosecant theta is hypotenuse over opposite. So that would be 2 divided by negative 1, or just negative 2. Secant theta is hypotenuse divided by adjacent. So that's going to be 2 divided by the square root of 3, and we'll rationalize that. So that is 2 square roots of 3 over the square root of 9, which is just 3. And last but not least is cotangent theta. And actually, I put theta in here, but I want to fix something. So before we go, I'm going to fix one thing, because theta actually has a number. And I shouldn't have just put theta in there. Although I've labeled it with a reference angle, we should really write the exact value. So we're going to fix these thetas before we go. So cotangent theta is the adjacent over the opposite. And so that's going to be square root of 3 over negative 1, which is just negative square root of 3. So sometimes I get a little lazy and I put theta all the time. In reality, we're not just finding, we're finding a specific theta, and that is we're finding sine negative 30. So this is the sine, cosine, tangent, cosecant, secant, and cotangent for a negative 30-degree angle. Right? It also works out that they would be the same for a 30-degree angle, but notice that that's not our typical 30-degree angle. That 30-degree angle is in the fourth quadrant. Right? So normally a 30-degree angle is in the first quadrant. A 30-degree angle in the fourth quadrant, right, is going to going to change our signs, because now we're going to have two that are negative. And so technically, back over here, I shouldn't have put just theta. I was being a little lazy. So let's change that. You can just put, the number above it. So technically, this is sine 120, cosine 120. Let me fix that. Tangent 120, cosecant 120, and secant 120, and cotangent 120. And finally, this was a very specific theta, so I should have filled in the value for theta on the first one. And so these here, instead of just theta, I'll put the actual value. It's sine 315, cosine 315, tangent 315, cosecant 315, and secant 315. And there we go. All right, so that's the end of this podcast. We've now, we missed one person. One little trig function. And in the next podcast, we're going to do the same thing, but in radians. Thanks for watching. Bye for now.